Okay.
Hello, everybody. We are Team Identity, and our challenge is how to make the collaboration in BIM and working with BIM as like working and collaboration with in a software development. So, if we consider BIM models as datasets or pieces of software, right now we have no ability to make connection with those software. So let's imagine putting all those software in a common data framework that enables this connectivity between those pieces or sets of data. So what we are suggesting is a, a different approach for collaborating in BIM in terms of not converging the data, but connecting the data.
So to make everybody clear what we are struggling every day about, like participating in a BIM process, we found a real world participant. That is Anna, is an architect, and this is Hugo, who is a structural engineer. Anna's working with Revit, making models, and he is working with Outplan. And they both participate in the same BIM process. And the question is how their ideas gather in one model or one project. So now I show you how this nowadays works if you work in an architecture office. So all participants of a project, like the architect, structural engineer, or others, making their own models in their own native software. They make an export to IFC, load them up on a common data environment or a cloud. Then some other guy is taking these IFC documents, make a collision work, make issues out of it, if there are changes or collisions, and report it back to each of them, and they have to put it back into their models, which is a quite time-consuming process, and it takes about 14 days to just consider, like, to detect a change. So Anna finds that really bad, and Hugo's even quitting his job. And while leaving his office, he passes through his friend Chris, who's a software developer, and tells him collaboration is easy in GitHub when you are a software developer. So he thinks, why can't we do it like easy like they are doing it? So remove everything which is bothering us and think about a process which contains a database which is actually going in two ways and not in one way in a circle. So that is the basic idea.
Okay, now we want to talk about the technology. So state of the art is that everybody has their own entities, and the entities have informations and geometrical representations. So every entity has a native ID, like a GUID, and they already have different geometrical representations, one for 3D and multiple for 2D. And when different people collaborate, they often talk about the same, like the same column, but they use different software and they use different entities. And so these entities have different native IDs, different GUIDs, but we think about those as really the same thing, the same column, and just different graphical or informational representations of the same entity. And to represent that, we want to take the workflow of software engineering and go to GitHub, create a master database where we put a master ID and we put the IDs of every software. And so we can now link the two entities together. And so we can now access information about an object that might be in Revit, but we can access information from ArchiCAD via this database. And keep in mind that the information can be everything from parameters to even the graphical representations.
So at the core of the problem is an idea of identification, so that we have the different pieces of software agreeing on what something is, but we're not allowed to force new workflows. This is my challenge as a developer. It'd be very nice if I could get everyone to agree on a file format and a process, but they don't. We live in a chaotic world where data and processes and tools are all varied. and we just want to connect it together so that we have a single vision of a true unified BIM model, not a project with all sorts of crazy documents. So the principles that were laid out to me by the team were saying, we want to see information ideally in the native software. We don't want to export to something else to see a collision or a clash or even a change, even though that may be a possibility. We don't want you to touch our workflows. We're not going to do anything different, no matter how often your tool is. We need to specify where the data originates. Because the data lives in different places, we may agree on where the same thing is, but now we have to backtrack to say, well, some of that data is over here and some of that data is over there. So we need to backtrack and reference the data. We need to quickly detect changes. One of the key things is for people to know, something's changed in the project that's relevant to me. That structural engineer moved that beam, I want to know immediately, but better yet, I want him to know when he moves it. And so everything should also be able to be viewed. All right, let's next. When we talked about this, there are so many challenges ahead of us. And so our primary contribution here is to actually explore the feasibility. We can't solve the problem today, but we say it is possible to solve the problem, and it is valuable to solve the problem without going to hey, everyone just use tool X, format Y, CDEZ, because that's not going to happen in the near term. So we had a few challenges. One of the key ones is obviously the first challenge. I have two files, they're talking about the same thing, but they have different IDs. So how do we resolve that? Another problem is that different geometry representations exist across the softwares, even within a single software, and they are all valid. So we wanted to merge. Let's go to the next one. So this is one that caught some people's eyes. So for the computational people in here, it's like, how do you solve the problem of mesh similarity? This is not a solution. There's obviously edge cases. Wow.
Just go on.
Okay. We wrote code for doing this. Our model is text-based. It's actually JSON. This is a visual diff within a coding tool. We can put it in a GitHub, submit a pull request. We can code review the information model and say, hey, engineer, why are you doing this? We can approve, reject. We just are using this information model, store it as a text file, put it into GitHub. We didn't have to write any tooling for that.
Okay, and this is how we make our collaboration simple. So we create elements, for example, in Rhino. We send it to GitHub. And then Anna gets really happy because she doesn't need to do anything right now. She just received the changes in Revit. And she receives the ID of elements that have been changed, they marked red, and she also sees the element that's marked as a green where the column, for example, should be moved. And now she can just accept the change, reject it, or send her own changes. Okay, and that's applicable for other softwares as well. Thank you.